Okay, so I changed the numbers. I said 30 for V and 55 for degrees. So to find the maximum height, all you have to do is plug the information in. Later on in calculus, we'll learn a technique for how to find the maximum of a single variable function, but right now we don't have those tools in our tool belt yet. So we're just plugging in 30 in for the velocity. This is sine squared, and then theta is 55. And then it says the gravitational constant is 9.8. I don't know if that's the right word. That gravitational acceleration constant, that's right. Okay. So when you do this, just make sure your calculator's in degrees, because that's what we were given. Do sine first, probably, and then square it. That's what that notation says. Square the result. Another way of writing this would be all this. Find out what sine 55 is first, then square it. So here I'm going to use the squaring button. And then I'm going to multiply that by 30 twice, because that's the same thing as 30 squared. And then I'm going to divide it by 2, then I'm going to divide it by 9.8. So for mine, this thing is only going to go 30.8 meters, because we're in meters with our units. 30.8 meters. And then how far horizontally, I'll leave that for you. It's just the same thing. You're just plugging in 40 in for V and 45 in for theta into the bottom formula, because R, it says, is the horizontal distance. Okay, so for part 2, just another type of function that we use in calculus, something that we can see a real-world application to. This is a logistics function. What it is a function that it accurately models population growth. Eventually it levels off until you've reached max population. Maybe it's geographically because of oceans around it. Maybe it's because of geographic restrictions because it's a bacteria on a slide. Maybe it's food constrictions for an animal out there. But logistic growth looks like this. It levels off after a while. They want us to say how many days will it take until the pond has 100,000 fish. So I'll do 200,000. I'll keep everything else the same. We're looking for time. They said how many days. So we're trying to solve for t. The 200,000 is a population, so I'm going to plug that in over here in the formula. 200,000. And then we got, oh, here, I got to change this number too, because that's max capacity. So I'm going to put, let's change it to 300,000, because I might give away a trick. 300,000 over 1 plus e, and we'll keep everything else the same. Negative 0.0005 t minus 10. You're trying to solve for t. It's in the denominator. That's the first thing we want to get rid of. So you want to multiply both sides by this entire denominator. 1 plus e to the negative blah, blah, blah. I'm not going to try to write all that out again, because that cancels it out in the denominator, and it leaves us with the left side being 200,000, 1 plus e to that crazy exponent, and then the right side is just 300,000. So we've got t out of the denominator. We can distribute this 200,000 to try to help us get t by itself. So it's going to be 200,000 plus 200,000 e to that crazy exponent equals 300,000. And the goal is to get t by itself. So t is in this exponent position. We're going to get to that in just a second with pre-calc stuff. Let's subtract this 200,000 from both sides to make our equation even simpler. And then we're still trying to get t by itself, so this is multiplying. Let's divide 200,000 from both sides. So we get e to that crazy exponent equals 0.5. 100,000 divided by 200,000 gives us 0.5. Okay, so I'll put that crazy exponent back in. Negative 0.0005 t minus 10 equals 0.5. So in pre-calc, we learned if a variable is in the exponent position, we can take a logarithm of both sides in order to get it down. And I'm using natural log because natural log is a logarithm base e. So natural log of an exponent base e, they cancel each other out, and leaves us at just the exponent. Now this over here, natural log 0.5, that's just a number in your calculator. So 0.5 natural log. And then the rest of this is just straight algebra, nice and easy algebra, right? This is negative 0.693 over here. So just algebraically get t by itself, and then you've got your final answer. But this, remember, is I changed the numbers. You're going to do the same steps. I just walked you through the most difficult steps.